In this video, we're going to be learning about identifying and classifying polygons. Make sure you have a pencil, please, before you start your notes, and go ahead and write your learning target in on this line here. So I can identify and classify polygons, and then if you need to, stop the video so that you can fill in all of the vocabulary information. However, it is a best idea, of course, to listen to the instruction that goes along with all of this vocabulary. So some important vocabulary is going to begin with the word polygon. So a polygon is a closed figure formed by three or more line segments called sides. So the smallest number of sides that a polygon can have is 3, and you may recognize that as a triangle. So a triangle is a polygon. It's a three-sided polygon, and of course there has to be closure. Nothing can be open. So if you saw something that looks like this, that is not a polygon. Okay, so we would not consider that a polygon because it's not closed. The other thing about a polygon is that it cannot have any curves on it. So we cannot call a circle a polygon. Okay, so it has to have sides and it has to have vertices. That's the plural form of vertex is vertices. So there has to be these points where the sides come together. Okay, each side intersects exactly two sides and one at each endpoint, so that no two sides with a common endpoint are collinear. And each endpoint of a side is a vertex of the polygon. So in a, let's just say in a rhombus, something that looks like this, where all the sides are congruent. Okay, rhombus is a quadrilateral. Notice that there are four sides. It is a closed figure, and there are four vertices. Okay, so these are called vertex if there's just one, but if there's multiples, then we call those vertices. A polygon is convex if no line that contains a side of the polygon contains a point in the interior. So a convex polygon would be something like maybe like the shape of a house where none of these vertices are kind of indented. Okay, that's called convex. If it's concave, notice that concave, and I kind of remember it this way because it kind of looks like a cave, because it would be something more like this where there's like an indent. Okay, so if this part is kind of going into the figure, then that would be called concave. Okay, so anything that has an indentation is another way to remember that. So the word cave or indented, those are the ones that are called concave. And we are going to be asked to identify which kind of polygon we have been given. So you should know the difference between concave and convex. The term n-gon, where n is the number of a polygon's sides, can be used to name a polygon. So for instance, if I said, what is the name of this figure, and it had 17 sides, then it's going to be called a 17-gon. Okay, or if this shape had 65 sides, that would be called a 65-gon. So rather than giving 65 a funny name, we would just call it a 65-gon. Sort of like a pentagon is 5 sides. Okay, we don't call it a 5-gon. We actually have a name for that one. That's called a pentagon. But as the numbers get larger and larger, we don't have enough funny names to give those. So we're just going to name them the number of sides, and then hyphen, and then G-O-N. Okay, if all of the sides are congruent on a polygon, then we call that an equilateral polygon. If all of the angles, the interior angles of a polygon, are congruent, then we call that equiangular. And that is a hard word to spell and to say. Equiangular is a polygon with all of its interior angles that are congruent. And we will have some examples of each of those as we go through this set of notes. The final word here, the word regular, means that all sides and all interior angles are congruent. So for a square, if you think about what a square looks like, remember the angles on a square are 90 degrees, so they're all congruent. And all the sides have to be the same as well. So a square is one example of a regular polygon because all of its sides and all of its angles are congruent. Okay, so that's just one example. So we're going to go ahead and look at example number 1 here. And in example number 1, we're going to tell whether the figure is a polygon and whether it's convex or concave. Now, just to remind you, concave is the kind that is indented, so it kind of looks like it's been smushed in say at some point. Okay, a polygon is a polygon if it has sides, if it's closed, so it cannot be open, and it cannot have any curves. Okay, so no round pieces, no round parts to this shape. So in number or part A here, would this be considered a polygon? Well, it does have 5 vertices, it looks like. Here's a vertice, here's a vertice, and I could call them vertex, but plural is vertices. So there are 5 of those, and the shape is closed. All of those vertices connect the sides. Okay, so yes, this is a polygon. And is it convex or is it concave? Well, it looks like it has a big indent right here. So we'll have to say that this is concave. Okay, you can think of a cave going into a mountain or a hill. So that's going to be the type of polygon that it is. Okay, if we take a look at part B here, is this a polygon? Well, we see that there's this big arc here, kind of a curve shape. So this cannot be considered a polygon because it has the round shape. So we don't have to say if it's concave or convex because it's not a polygon at all. Okay, and no curves allowed, we'll say, in a polygon. And for part C, we have this shape. Now, this looks like a polygon. However, it has this segment which connects the two pieces. So this is not a polygon either. And the reason is because it cannot have any interior sides. No interior segments are allowed in a polygon. Now, if this was called a diagonal, that's a different thing and that would be acceptable. So had this piece right here not been here, this piece in the middle, if we didn't have this piece at all, this would be a concave polygon because we would be looking at the sides on the outside here, and if those were the only pieces, then we would say, yep, this is a concave polygon, but we can't say it is, so not a polygon. And finally, we have here part D. Part D looks like it is a polygon. There are sides, they're all closed, and there are vertices that connect those sides. And this is a polygon. Now, what kind of polygon is it? It is convex because none of the sides are indented. So we're going to say this one is convex, and that's because all of its vertices are pointing outwards. They're not indented. So no indents makes it a convex polygon. And for your part here, before you get your stamp on your notes, you want to make sure that you do the on your own portion here, and you're going to tell whether the figure is a polygon and tell whether it's convex or concave. So this is going to be very, very similar to what we just did above. Go ahead and turn your paper over. There's one more thing. Actually, there's 2 more things that I want to discuss here. Okay, in example number 2, they want us here to classify polygons. So we actually have to classify the polygon by the number of sides. So just to refresh your memory a bit, and I know you probably have had some instruction on polygons previously, the number of sides that we're talking about, so if the shape has 3 sides, it's called a triangle. Okay, if it has 4 sides, it is called a quadrilateral. It's a long word to spell. Trilateral. Okay, if it has 5 sides, then it is a pentagon. A 6-sided figure is a hexagon. And a 7-sided figure, this might be a little bit strange for you, heptagon. Some people try to call it a septagon, but it is a heptagon with an H. An 8-sided figure is an octagon, like an octopus. 9-sided figure is a nonagon. You may or may not have heard of that one before. And a 10-sided figure, I'll just write it over here, is called a decagon. Okay, there's no special name for an 11-sided figure, so we would just call that an 11gon. But if you find a shape with 12, so I'll just write that right here, 12 is called a dodecagon. So sort of like a 10-sided figure where it's called a decagon, a dodecagon is a 12-sided figure. So the directions here say classify the polygon by the number of sides and tell whether the polygon is equilateral, equiangular, or regular. Now remember, equilateral just means has the same number of sides. Actually, the length of the sides is the same. An equiangular polygon has all angles the same measure or congruent. Regular means that both the polygon is both equilateral and equiangular. So, and then it also asks us to explain our reasoning, and that's important because in geometry we're going to be doing a lot of explaining. So we're just kind of introducing it in a few lessons here and there, but as we move forward in the class, we're going to be doing a lot more explaining in a lot more of our problems. So let's take a look at part A here. How many sides does this figure have? Well, it looks like there are 4 sides. So this is a quadrilateral. We also have to state whether it's equilateral, equiangular, or regular. It looks like, based on these little hash marks here, these 2 end sides are congruent. And then, because this side has 2 and this side has 2, those 2 sides are congruent. So all of the sides are not congruent. So we're not going to say this is equilateral. But I do see that all of these angles are marked with a 90-degree angle marking. So if they're all the same angles, you know, the measure of them is all the same. So this is going to be called an equiangular quadrilateral. Okay, so it's equiangular because all of its angles are the same measure. If we look at the example B, let's count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 sides, and we said that that is going to be an octagon. So this is an octagon because it has 8 sides. If we look at all these little markings, you may or may not already know, these little hash marks mean that all of those sides are congruent. Okay, if it has one single hash mark, then that means it's congruent to all the other ones that have a single hash mark. And if we see these little arcs on the angles, and they all are looking pretty much the same, one single arc on all of them, and that means that all of the angles are the same. And what do we call things that have equal number of, or sorry, the measure of the angles are the same and the side lengths are the same? That's called a regular shape or a regular polygon. So this is a regular octagon. All the sides are the same length and all of the angles on the interior are the same measure, and it has 8 sides. So it's a regular octagon. Finally, we have C here. And C looks like it has the 3 sides, so this is a triangle. And we have to state whether it's regular, equiangular, equilateral. Well, there's 1 arc here, 2 arcs here. That means that those are not congruent. This one is not congruent to any of the other angles, and this one has 3 arcs. So none of the angles are the same measure. They're all different, actually. And then it looks like the one side has 1 single mark, two side, you know, 2 markings here. So none of these sides are congruent either. So actually, this is called a scalene triangle. We didn't introduce the word scalene really yet. We're going to get to that a little bit later in another unit. But this is just a triangle. It's just a 3-sided figure. It's not equilateral, it's not equiangular, and it's certainly not regular because it's not either of the other 2. So if you go down the page a bit, you're going to have a couple problems to take a look at as well. Number 5 is asking you to do the same thing. So classify the polygon by the number of sides and tell whether the polygon is equilateral, equiangular, or regular. Don't forget, you do need to explain your reasoning. Okay, so sort of like what we did in the previous examples. Okay, let's take a look at example number 3. We're going to find side lengths. Now this has a little bit of algebra in it. And so it says the figure shown is a regular pentagon. Well, what do we mean by regular? It means that all of the sides are the same exact measure. So if they're all the same, so things that are equal, we set equal to each other. So this side that has the marking of 2x minus 1 is going to be equal to the side that is x plus 3. Now they gave us a unit of measure here that is centimeters. So when we get our final answer, we're going to have to put our answer in centimeters. So we're just going to go ahead and solve this. I'm going to go ahead and add 1 to both sides because I want to get rid of this term here. If I bring down my 2x, I still have an x plus. Now 3 plus 1 is 4. And in order to combine the terms with an x, I'm going to go ahead and subtract an x from both sides. That leaves me with just 1x here. That's completely gone. So it looks like x equals 4. Now it tells us to find the length of a side. It didn't say just solve for x. So I'm going to have to go ahead and plug my 4 back in here. And just to verify, I want to plug it back in here as well. So let's go ahead and do that work over here. So 4 plus 3 equals 7 centimeters. Okay, so that means we checked that one. And then I'm going to go ahead and say 2 times 4 plus 1. Oops, that's not a plus 1. It is a minus 1. Okay, so 2 times 4 is 8, minus 1 is 7. So I can check and say, yep, that one also is 7. And we were looking for side lengths that would be congruent because we knew that they were congruent based on the fact that they are, well, this is a regular pentagon. Okay, so in the last on your own problem, you're going to need to do something similar, and I did put a little hint here for you. Remember to solve for x and then plug x into, you can just plug it into 1 to verify, but I do need to find the length of one of the sides. In this case, they gave you millimeters as the measurement. Okay, so you're going to be looking to solve for x and then plug it back in to find the length of one of the sides of the regular hexagon. Alright, so tomorrow we'll be talking about equiangular, equilateral, regular, concave, convex, and the different types of polygons in terms of n-gon, octagon, hexagon, etc. So please be prepared to answer some questions about things related to polygons. Thank you so much.